So acanthus.com, acanthus.com. Check it out. So we're going to talk right now about bevels, chamfers, and miters. Now, for me, I mean, it's easy. You can differentiate between bevels and chamfers and miters pretty easily, right? At least between the first two and the last one. A miter, you're trying to get rid of and hide all of that end grain. You can do it as a picture frame. It can be done as a box. You can use miters to put up crown molding, all of those kinds of things. But what's the difference between a bevel and a chamfer? Well, for me, the way that I've always defined it is a bevel runs the entire width or thickness of a board. I mean, it's running across from edge to edge on, or from face to face on a board, right? Whereas a chamfer is more of a decorative element that is just a part of. So I could bevel this down, I could chamfer this down and have the tiniest little flat left on the end of that, and because it doesn't go out to a sharp edge at both sides, I'm calling it a chamfer. If it goes all the way through from face to face, I'm calling it a bevel. That's not to say that this is a bevel, because it goes all the way through, but in this case, it's actually used to create a frame. I know, confusing. It's kind of like that dado and groove thing that I talked about a couple of weeks ago. They're the same thing. This and this are essentially the same. It runs from this edge to that edge, this face to that face. Why wouldn't I just call that a bevel? Well, I don't know. I have to be able to figure out some way to differentiate these things from one another. So for me, that's a miter, because I'm trying to wrap it and bring it together with another piece of the same width or of different width. Here, because it doesn't go all the way through, I'm calling it a chamfer. Whereas this one goes all the way through from face to face. No matter which way I look at it, it is a bevel. We're going to start with the easy two of the three. We're going to start with chamfers and bevels, give you some quick tips on how to work those at the table saw and do it safely. Depending on the type of saw you have. There are two different types of saws. You have a left tilt and a right tilt. Personally, I think you ought to have one of each, and if you're looking for an excuse to go buy a second table saw, you've just been given permission, and you can blame the whole thing right on me. I'm good with that. I happen to have both a left tilt and a right tilt saw here in the shop. They work out great for being able to complement one another, because each one has strengths and weaknesses, and you'll see exactly how those things play out when we put on a couple of bevels and a couple of chamfers here at the table saw. Let's get started. So I want to put a 1/4 by 1/4 inch chamfer on this thing, just up this one edge and down the end. I could do all four. So I've measured up 1/4 of an inch, and since it's 1/4 by 1/4, that makes it a 45-degree angle. And the first thing I need to do is tilt my saw blade over to 45. So I'm going to raise it up a bit. Kick it over to 45 degrees. And now we got to get that height set. So using my pencil mark, I raise it up until it's just slightly higher than the mark. And then I'm going to bring my rip fence in as a stop, except I'm not going to use the rip fence itself. I've created a small L fence here that I want to get into position. I'm clamping that onto my rip fence so that it is above the height of my blade but below the top surface of the board. And now I can bring that saw blade around and fine tune it till I am right up against my mark and lock it down. And now we're ready to cut safely. And now what you'll see is when I cut this material off, it's not trapped between the blade and the fence. There's all of this extra space under here that it can go. So let's give it a shot and see what happens. In order to make the exact same chamfer at a left tilt saw, I've drawn in the chamfer that I want. I need to tilt my blade over to 45 degrees. I can set my height. It doesn't have to be the blade doesn't have to be anywhere near as high on this side. And once again, I'm going to bring my rip fence over and get it set. Now putting the chamfer up the edge is going to be a whole lot easier than putting it across the end. And what I like about working with a left tilt saw is that if I lift my material up, or if I'm working with something long and either going in or coming out, it tilts. I'm not cutting deeper into the material that I want to keep. So let's see how this works. Now, in order to run the chamfer across the end, I've got to use my miter gauge, and I've just extended the chamfer across, so it's as simple as lining it up. Now, what you saw using the L fence makes it ridiculously quick and accurate to get the exact same bevel all the way around. If I'm lining this up by eye and I've got multiple pieces, it becomes a whole lot more problematic to get the exact same thing. Of course, I could set a stop at the right end of my board for multiple pieces as long as they're all the same length. The other alternative is I could set a stop block out here using my rip fence and a step-off block. So if I want to run a bevel on the edge and the end of this board, because of the right tilt on this saw, if I'm using the rip fence, it might appear to be a little scarier than the left tilt saw. You'll see that in a little bit. So first thing I need to do is set using the protractor here, I set my bevel at 22.5 degrees, which is what I'm looking for. I can then set my saw blade right over at the proper angle. There we go. Set my blade height. I only want about 1/8 of an inch above. And since I have that bevel set, I can put a mark directly onto my board. It's as simple as lining up that mark with the saw blade. Now you can see this is tilting towards my fence. I have the fence in the low position. If your fence doesn't go down there, you're really going to need to be very careful in that space in between the blade and the fence. Well, you need to be careful anyway because, well, it's dangerous. So I'm going to use a push stick and we're going to make the cut. So using the rip fence, that bevel comes up nice and easy. If my material's a whole lot narrower, it might get a little squirrelier in that space, so you might want to find a different way to push your material through. The great thing about a right tilt saw is the widest part of your board is always down on the table, so it's less likely to tip over. Normally, on the sliding table saw, what I would do is bring that material over and work on the left side of my blade. Because this is fairly narrow and I'm hardly hitting my fence, my miter gauge fence, I can bring in a nice little fixture here, which is a 45-45-90 triangle that I made, clamp it to my fence, and now at that point I can take and hold this material down and run it right by the saw blade, and the waste material just falls off. Okay, to do the end cut, it's going to be a little trickier. I have to mark it on the end exactly where I want it. And now it's just a question of lining it up and cutting it off. See how tricky that was? To run the bevel on the edge of this board, we're going to do the exact same thing that we did on the hammer saw. I'm going to mark the 22.5 degree angle on the edge of my board. Get my angle set perfectly on my blade. Set the height of my blade. Bring it over and line it up perfectly with that pencil line. And now you can see the difference between a right tilt saw and that left tilt saw. Once again, the blade tilts away from the fence, so I've got a whole lot more clearance here, and if that board were to rise up or drop down at all, it's not cutting deeper into the part that I want to hold on to. And having a left tilt saw makes it really easy to put the bevel on the end. All I have to do is start the saw, use my miter gauge, and come in and line it up with that cut. What I've done is I've lined up a left pointing tooth on my cross cut blade with the absolute corner of my block. And I just make the cut. Once again, if I'm doing pieces, if I'm going to bevel multiple pieces of the exact same length, I can set a stop block at this end so that my pieces are always beveled in the same direction at the same overall length. If they're varying lengths, what I could do is line that blade up with the end of my block again, and then I go back to my rip fence with a step-off block, bring it right over, and now I can make repetitive cuts relative to that end. And right there you can see one of the disadvantages of having a left tilt saw. That piece that comes off of there is wedge shaped, and because it's a left tilt saw, the narrow side of the wedge is facing down to the table. So that could and did get stuck between the blade and the throat plate. But overall, not such a bad job. And now you've seen the difference between a left tilt and a right tilt saw where it concerns chamfers and bevels. Let's get into the important part of this, all about miters. So let's talk a little bit about miters. If you came to the live shows last year, you probably remember this box going on. Last year we made one each week using the Hammer C3 combination machine, and at the end of each show we gave it away. So what this one is missing is some kind of a base molding, and I'm just going to use a little bit of pine here. I'm not actually going to attach it to the box, but the box gives us something to envision as we're trying to figure out exactly what mitering is and how it works. So the first thing I've got is I've got it sitting on top of this piece of plywood, and I'm just going to mark off the existing corner of the box. I assume that it's square, but I don't know that for sure. And if this is my base molding and I'm going to wrap it around on all the sides of the box, this corner may not be the same as that corner or that one or that one. So in order to get nice tight-fitting miters, especially out of a piece of molding, we've got to have a way to calculate the exact angle at which to cut each piece in order to get the perfect miter. So theoretically, if I just hold one piece of molding up against my box and I trace the outside edge, just like that, and then I put the other piece of molding in there, and I trace the outside edge. If I move my box out of the way, the reality is, if I connect this outside corner of the box to the outside corner of where the moldings cross, that is exactly the angle that I need to cut. In this case, I'm reasonably sure it's going to come out at 45 degrees, and it does. So to cut that, I've got a couple of fixtures that I had made, which if you come back for the CNC Basics class later on today, you'll actually see how I made those fixtures, although for years I've just made them at the table saw and using a drill press. But I thought I'd play. So if we head over to the table saw, I can show you how I use those fixtures in order to create that perfect 45 degree. But before we go, there's something else I want to show you. Suppose you're mixing two different things. You're wrapping, molding around something that you have two different size pieces of molding. So I've got one that's, oh, this is about 1.25 inches, and then I've got one that's 1.5 inches. For some reason, you want to mix and match. You want to bring in two different size pieces into a perfect miter. It happens. It doesn't necessarily always happen with molding, but I'm going to do the exact same thing. I've got my box line back up on my corner on my piece of plywood. Put the wider molding where it goes, hold it in place, scribe off the outside. Now, when I move the box out of the way, I connect that outside corner of the box to the outside corner of my miter, or my molding, and now this is my angle that I have to cut. So you'll see the fixtures that I made to cut the first one. I have ones to cut 45 degrees. I have ones to cut 60 or 30 degrees. And actually, normally I even make them up so that I can make 22.5. And those are normally about all the angles that I'm going to need. This final angle, because the two moldings are different widths, here what I'm going to have to do is grab a bevel and set it to the proper angle. Based off of my drawing. And then set my miter gauge to that specific angle. And I'll even show you a few ways. I'll show you using the fixtures on the table saw sled how I can tweak the miter to tune it up just to make it absolutely perfect. So let's head to the table saw and show you how I would make some perfect 45 degree angles with a nifty little fixture that I made up earlier. So now that we want to cut our miters, the first thing I did was I made a handful of these 45, 45, 90 triangles. I've also got 30, 60, 90 triangles in case I want to make hexagons or something like that. But for standard frames and picture frames, moldings, things like that, the 45, 45, 90 triangle is good. I drilled a couple holes in there. Actually, these were machined out on the CNC machine. So if you come back later today for the CNC basics, this is one of the projects that I do on there. So to set them up, I brought them in until they were just snug. I have two of them on my sled here. Normally, I have a narrower sled that it's about 14 or 15 inches wide and runs in the same miter gauge slots as my regular crosscut sled. But somewhere in the last couple of months, it got turned into a dado sled. So instead of taking the time to make up another narrow sled that would just eventually get turned into yet another dado sled, because for the most part, I'm setting the miter gauge fence on my sliding table saw to whatever angles I need, and then cutting my miters, or I'm cutting them at the miter saw. But if I've only got a table saw, if I make up two of these simple triangles, cut them as accurately as I can. I brought them in, like I said, you can see I'm right up against the edge of the saw there, so I'm actually getting a zero clearance on my piece, I know exactly where the cut is going to take place. Now, I'm going to cut both of these, and then we're going to check the miter to see if it's actually 90 degrees. If it is, then if I know my case is exactly 90, then I don't have anything to worry about. But then I'm going to show you how to tweak it in case your case is not square. So let's make a couple of cuts. And now we'll check the miter to see if it's perfectly square. So if I pull those together nice and tight, and then check it for square, comes up absolutely perfect. But what happens if the toe of your miter is open when you put it around the case, or the heel? So this is the heel, and this is the toe. So what do you do if you wrap it around your case and it's open at the heel or it's open at the toe? How do you adjust that given that you have a fixed 45-degree block? Because my blocks are set at 45 degrees, and if you're using a miter gauge or you're working at a miter saw, you may have absolute detents that lock you into that exact 45 degrees no matter what. So if I'm open on the toe and my heel is tight, that means I need to take more off the heel because that's what's tight. So one of the things that I do is I use a little bit of scrap sandpaper. I've got some 220 grit here. It's on an A weight paper, so it's kind of light. Just a sheet or two. If I put it close to my miter, get it out of the way so that I can see what's happening. If I put it close to the heel, I'm only moving off of there a fraction of a degree. If I bring the material in and push it tight against the saw plate, not against the teeth, so I may have to raise my blade up just a touch so that I'm not touching the carbide. And what I do is then hold it in position, bring it back, and now I can make a cut. And what it does is it'll take slightly more off the heel than the toe. If it's way out and I need to go more, I can take that same shim, my sandpaper, and move it away from the miter. And what you'll see is the gap here grows greater between my workpiece and my 45-degree angle. So if I go back in, touch the saw plate, bring it back and cut. And now since I took a little off of each heel, you can clearly see I've got almost a 1/16 of an inch out here where my fingers are. So I'm under 90 degrees. So with the sandpaper roughly in the middle of my block, you can see as if I hold back here, I'm tight, and I've got almost a 1/16 of an inch gap out there where I'm going to cut. So what that does is it's going to cut more off the heel than the toe. If I put my miters together around my box and it's tight out on the toe and open in the inside corner where the heel of the miter is, that means I need to take more off the toe. So instead of holding my material tight farther away from here, I reverse it. Now I'm open back here and tight up top, and I will end up taking just a little bit off the toe of that miter. The idea is the more I move it towards the area that's being cut, you can see now my my gap is a whole lot bigger here, so I'm going to take more material off that toe. If I switch my pressure to come back away from the fulcrum, which is my sandpaper, I create a small gap. If I move the fulcrum closer to my, or my pivot point closer to my pressure, I increase the gap. So depending on whether you have a big gap at the heel or a big gap at the toe, or a small gap, whatever, you're going to move your pivot point accordingly to create a bigger cutoff either on the toe or the heel. Well, there you have it. You can see, hopefully you've picked up a few really good tips along the way. For me, the takeaways are try and make yourself an L fence for the saw, because it makes running those chamfers super easy, super accurate, and really fast. Bevels, personally, I prefer the left tilt saw, but if you have a slider like me, you can do everything from that sliding table and create those bevels safely and quickly and easily. And finally, keep your scrap sandpaper around. It's a really great little thing to shim up, kick those miters around just in one slight direction or another, so you can just tweak them, whether you're working at your miter saw or you've made up the triangular fixtures that I have on my sled. So I hope you enjoyed the seminar. I hope more importantly, I hope you learned a lot of really great little tips and tricks along the way. I'm going to open it up to questions at this point. If you have them, please ask. If you don't really feel comfortable asking during the seminar in front of lots of other anonymous people, feel free to head over to my website, and you can send me an email from there, or you